seconds for the live streaming to start. Hello, everyone. Welcome to the Starknet Foundation Resolve Hackathon workshop number 8. While we give people more time to join the call, I'm going to share some important links that we have been sharing for many times now, in case you don't have it yet. So if you haven't registered for the hackathon, please make sure to register for the hackathon. We also have a hackathon Telegram group. It's very, very important that you join the Telegram group because you can find teammates there. You can find lots of resources there. You can also ask questions to all the mentors there. So it's very important that you join the Telegram group. You can also add the hackathon workshop calendar to your Google Calendar so you don't miss out future workshops. And if you do miss past workshops, you can watch the hackathon workshop recording on our YouTube playlist. So I send the links into our chat. Let me see whether it works. Okay, the live stream is working great. Perfect. Okay, so now today we're having the 8th workshop, as I mentioned, and we have Casio here with us. He's from Fat Solution. Casio, can you introduce yourself a little bit about Fat Solutions and give an overview of what you are going to do today in the workshop?
Yeah, sure. First, I wanted to know if there are other attendees that can open the mic, or it will be just
no, it's just you. There will be
okay,
a chat
perfect.
or maybe in the QA box. That's
Okay.
mainly it, and on social media.
Perfect. Okay, great. Okay, I'm Casio. I'm a developer at Fat Solutions. On Fat Solutions, we basically work on everything related to zero knowledge and privacy. We've been on that for the last 2 years. And hello, Felix. How are you? And yeah, basically we started working on Starknet last year, doing sumo logging, which was one of the first implementations that utilized Garaga. And yeah, since then we've been working with Starknet on sumo logging, which is a zk login using groth16 and verifying those proofs on Starknet on chain. Maiden, all privacy-related projects. We are also working on the privacy pools implementation for Starknet 2. We're working on the SDK on privacy pools, the relayer. I don't know, we're doing a bunch of stuff. And right now we're working on Tongo, which is a confidential ERC20 protocol for doing confidential transfers on mostly stable coins. But yeah, that's like a general thing. And I'm just a zero knowledge dev. So,
perfect.
Yeah.
Yeah, the floor is yours. You can start the workshop now.
Okay, perfect. Well, first, this workshop will be about Garaga. Garaga and Starknet are pretty important because I don't know if you're familiar with zero knowledge. How does zero knowledge work? What is a proof? What is a circuit? I'm not sure about how. Okay, I don't see any chat, but okay, Sergio says yes. So I guess you're all familiar with zero knowledge in general. As you may know, in order to have a zero knowledge proof, you need a circuit. And most zero knowledge applications right now that live on Ethereum on other layer 2s use Circom and groth16 in order to prove and verify on chain. But there's a thing that the elliptic curve that is used with circuits is BN254, and that's not completely compatible with the star curve. So we need kind of an adapter in order to verify those proofs generated with Circom on Starknet. But Garaga is from Atari. Yeah, maybe, but this is another Garaga. No, it's not Galaga, it's Garaga. Post-quantum problem also. Yes, Garaga, yeah. So yeah, on this workshop, I'll basically show you how to set up an application using Circom as the language that we will use for doing a circuit, and then we're going to use Garaga in order to transform those proofs in order to be verifiable on Starknet, because if it wasn't for Garaga, we wouldn't be able to do that. And then I'm gonna do like a live demo of it. And also, I don't know if it was shared. but I will give you some links, some resources links that will be useful for you if you are trying to build something related with zero knowledge and Starknet. There it is. Okay. If you're interested to go to the resources link, well, I'll do the presentation, may be useful. There's a lot of links with documentation on Cairo development, yeah, zero knowledge general stuff, Garaga documentation. Yeah, probably will be useful because sometimes it's a little bit difficult to find good docs indexed on Google for Starknet. So I took the time to index every useful thing that I found. So yeah, well, let's start with the presentation. Okay, I will go through the who am I just did that. So a little intro to zero knowledge for the ones that are not really sure about what's happening. I'm not going to get into math because I guess you're doing a hackathon and you need to ship something. So what is a zero knowledge proof? Basically, you do a zero knowledge proof if you want to prove some compute that happens off chain with some secret inputs, and then you can verify that on chain. So basically the flow would be you have a circuit, you have some inputs, some of them are private, some of them are public. And then you generate a witness that would be like a trace of that program called the circuit. And that checks that everything that you wrote on the circuit, that there are like a lot of assertions, it checks that everything went okay and you're doing a correct compute. And then that can be verified on chain. That can be verified on chain or off chain, but I think the cool thing is to do it on chain because with that's like a good feature for design because you can delegate a lot of compute locally to your computer or off chain or to a server, and then just do a small verify that costs a small amount of gas, and basically, yeah, verify that compute on chain. So, okay, it's a little bit quick. Then some use cases for zero knowledge would be right nowadays they're used for identity and credentials. Maybe you can prove that you're a citizen of a specific country without showing that the passport, for example. Let's say that you want to say that, hey, I'm from Argentina, but you don't want to dox all your data about your personal data. You just want to show that you're part of the Argentinians list, let's say. So you can build a circuit that does that. I'm not sure about how you do that, but you can make a circuit about that and prove with your private inputs, that would be your passport locally, that you're indeed an Argentinian citizen, and then send just the proof. And the proof is just a bunch of numbers and a bunch of stuff that gets checked and verified on chain. So that would only go through if all the assertions went okay. So if you wrote a good circuit, then you will be able to verify that you are an Argentinian citizen without showing your actual passport, let's say. It's the classical example that, yeah, like zk-passport, exactly. That's a pretty interesting application of zero knowledge in real life. Please, if you have any questions of if I'm not being clear on something, please ask. It's better to have feedback, so don't feel weird to ask stuff. Yeah, please. Then we have association sets, which is kind of a similar thing to what I just said. Is it implemented currently? I think zk-passport is, yeah. I think that's on mainnet. I think it's productive. So yeah, you can look at that and see the documentation. You probably will understand better how zero knowledge works. Yeah. So association sets. Association sets are pretty cool. They're right now starting to being used for things related to private money. For example, I don't know if you're familiar with Tornado Cash or privacy pools, but that's one of the first big applications that uses zero knowledge for a useful thing, which is having private transfers on Ethereum, on Starknet, or on any chain. And that was something that was pretty difficult to do before that. So yeah, as you may know, Tornado Cash had some problems because it got there were a lot of hackers that went into that and kind of privatized their money, but it was kind of a sketchy thing because it came from hackers. So an association set is a way to show that you are part of a certain group without showing who of those you are. So how does this apply to Tornado Cash? Imagine that there are, I don't know, 1,000 depositors, and one of them is a hacker, right? You could make an association set proof that shows that you are one of those other 999 persons that weren't hackers without doxing who of them you are, right? Does that make sense? It's like lowering the anonymity set to a certain level so you can show that you can still be anonymous, but you can show that you are not associated with this specific address, which is a hacker. That's a pretty cool use case, and that's what right now Privacy Pools is using. That's like the big feature of Privacy Pools. It's like Tornado Cash, but you have this association set with regular users and not hackers and that sort of thing. So it's pretty useful. And then we have confidentiality. Confidentiality is like privacy, but not the same as Tornado Cash. It's just like I can send you money. You can see who sent money and who received that money, but you cannot see the amount. That's a cool track that is starting to get developed like this last years. That started to gain a lot of traction. We're currently working on that on the Tongo protocol, and it's like an intermediate way of having not that much privacy like the Tornado Cash, but having confidentiality, like for example for stable coins or more compliant uses. It kind of makes sense. That's a cool track to investigate if you're building something related to privacy, because it's not like to do a classical mixer like Tornado Cash, because there are like, I don't know, 500 different mixers right now. So the confidentiality track is a pretty interesting one. I will probably give another workshop about confidentiality probably next week. So if you're interested in that, we can cover that. And and with Tornado Cash, I guess you all know what Tornado Cash is. So proving systems. Yeah. Okay, proving systems. Proving systems are the way that you prove your circuits and you can generate proofs, right? And there are different proving systems. Right now, there are two big ones. There are Gross16 and Plonk. And the difference between them would be that Gross16 requires a trusted setup in order to generate proofs, and Plonk uses an universal setup, so you don't have to do a trusted setup in order to create a circuit that can be verifiable on chain. And that may sound good, but the problem is that Plonk isn't that efficient as Gross16 is. So it's kind of a trade-off. I mean, if you want to do a trusted setup or not, it depends on what you're doing. If you're going to update your secret pretty often, let's say, that would be kind of a pain if you're using Gross16, and that may become more useful to use Plonk. But yeah, right now, like the biggest applications that support zero knowledge right now used Gross16. Right now, they're starting to use Plonk with Noir mostly. But for example, Tornado Cash, which is like the biggest application that had the biggest TVL regarding zero knowledge, used Gross16. So it's pretty battle tested. The tooling is not perfect. I mean, it's kind of difficult to do stuff yet, but yeah, it's the most battle-tested technology regarding zero knowledge right now. So yeah, on this little workshop, we're going to cover Gross 16 and not Plonk. If you're interested in Plonk, you can send me a message and we can figure it out. It should be pretty easy. I know that Garaga is now supporting Noir and Plonk, so that should be possible to do. So yeah. Well, Circom. What's Circom? Circom is the language that we're going to be using for the circuit. Circom is a DSL, the most popular language to do circuits right now, and it uses the Gross 16 proven system, and yeah, basically that it's like the most common language that you would be using for creating circuits and proving and verifying on chain. And you have a pretty good tooling that's called SNARK.js, which is a library for making all the proving client side, let's say. Yes, client side is a node library that you can import into your web app, and you can do proving locally on your computer. You can do verifies also locally, and you can generate verifiers like a solidity verifier, for example, with this tool. So it's pretty useful for zero knowledge development on chain. So yeah, our circuit that we will be using is like a super simple circuit. The idea is to show you how to connect all the boxes, and then you can develop whatever you want. Because I think the difficult part is to orchestrate all the boxes in order to make them work. Once you have that done, once you have the structure, then you can make the circuits more complex. But yeah, that's why I did this demo repo that I will be showing you right now. Please ask me questions if I'm being too quick or whatever. So this is basically
Casio,
curves.
there are two questions in the QA box.
Yeah,
Can you see
sure.
it?
Let me check.
From
Where's the QA?
Sanixin and Sergio.
Oh, here it is. Oh, I didn't know there was a QA box. Nice. What do you think about the vulnerability of trusted setup if someone learns the original keys, and why are snarks used instead of starks? Okay, that's a good question. Firstly, about trusted setups. If someone learns their original keys, usually when you do a trusted setup for a Gross 16, a Circom circuit, let's say, you will the trusted setup implies that a lot of people sends their randomness, their private randomness, into this trusted setup in order to make it really decentralized and not breakable, let's say. So if you, yeah, Sergio is saying, for example, Powers of Tao is a way to do trusted setups. As long as one person does the right thing, then it would be impossible to break the system. So that's why trusted setups are so important to do in a distributed way and to get as much persons, as much people as you can, by giving their private randomness to the trusted setup. So I don't know, the last, for example, the privacy pools trusted setup that was like, I think 6 months ago, was contributed by 500 different persons, 500 different people. That's really good, because if you, for example, if you contribute to the trusted setup and you delete your private data, then it would be impossible for someone to recover that. And yeah, it's pretty easy to get a good trusted setup and not have vulnerability over it. Then maybe you can start looking at the quantum secure thing of Gross 16, and that's a whole different conversation. But trusted setup, as long as they are big, and if you can contribute to that trusted setup, then you should be okay. Because if you do your contribution to the trusted setup and you get rid of that private data that you contributed to it, then you should be okay. Then, why snarks? Do we use snarks until Stark provers become scalable? How can you achieve truly decentralized snarks if a trusted setup is required? Um, Truly decentralized snarks, if a trusted setup is required, eh, I don't know if you can get it like to 100% decentralized, but it's pretty much decentralized as long as people contribute to the trusted setup. The thing about snarks and starks is that they're different, and the important thing here is that we are doing zk-SNARKs, not just snarks. And currently, as far as I know, there are no zero knowledge Stark. So yeah, we're using zero knowledge snarks because we need the zero knowledge part of the snark, which would be the ability to have private inputs on the snark. Let's say, does that make sense? That's why we're not using Stark provers. I'm not sure if there are zero knowledge Stark provers. As far as I know, they don't exist yet, at least. But yeah, that's why we're using snarks, because there are zero knowledge snarks, and that enable us to do private stuff, basically. And how can you achieve truly decentralized snarks if a trusted server is required? Yeah, I understand that it's not perfect, but if you have a decent enough trusted setup, you will be able to have this. You can trust it, but yeah, at the end of the day, you're trusting it. But if you contribute to that trusted setup, then you should be okay. As long as the trusted setup was done good enough, you should be okay with that. Then I thought Cairo is for Starknet, and I know Groth 16 circuit get converted to a Solidity file. How is the Groth 16 compatible with Cairo? That's a great question, and that's basically the whole purpose of this workshop, which is Garaga. That's why we're on this slide. Basically, Groth 16 circuit using Circom uses the elliptic curve called BN254. And that's like the canonical elliptic curve that you will be using with Circom. Yeah, I cannot give you much detail on that because I don't know that much about math. But with BN254, you will be able to verify and generate all the proofs you want with Circom. And that's currently compatible with EVM because the EVM supports that curve. But the problem with Starknet is that Starknet has a different native curve. It uses the star curve. And the star curve is a bit smaller than BN254, so it's not completely compatible. So that's why we need an adapter between both, right? We have to make these proofs, these verifies, basically. We have to make the verifier compatible with the star curve, and that's where Garaga comes here, right? That's why we need Garaga. Stu prover is CK. Then I guess we are not using Starks because it isn't that scalable. I didn't know the Stu prover is zero knowledge, but yeah, I haven't seen any application using the Stu prover right now. Okay, so here the adapter Garaga. Basically, what Garaga does is to convert or adapt this BN254 proofs that weren't compatible with Starknet into a compatible version of the verifier for Starknet. So it takes the verifying key from the normal Groth 16 setup and transform it into a verifier that is compatible with Starknet. So you can deploy that. It's written on Cairo. So you can deploy that on chain on Starknet and be able to verify Groth 16 proofs on chain. So you can do custom logic over it. You can do whatever you want. And right now on this demo, we're going to do a little proof, web app that does a little proof and then sends that proof into Starknet and verifies that on chain. So yeah. Okay, and now I'm going to show you the repo.
Hey, Casio, before
Please.
you start showing the
Yes,
repo, there's one more
yes.
question.
Let me see. Stark. I thought Stark uses polynomials. Okay. Not sure, Sergio. But yeah. Okay, let me get. Okay. Here we have the little demo I did. I'm going to show you the repo. Workshop repo. Okay, so here is the repo that I made. This should be on the Zoom call link. And here you can clone this. You can read the README if you want, and you will be able to follow the quick setup commands in order to do it yourself. But basically here, the important part is that what we're doing is basically making a circuit, which is here. Here we have a little Circom circuit, which is like an age verification. Yeah, I know it's super simple and it doesn't do a lot of stuff, but here we can prove that you are over 18 without showing that you are actually 18. Basically, we are checking that you are more than that the age that you put in here was bigger than 18, and then you're doing a hash with that age and a salt in order to have a public input to commit to that. And yeah, basically this is a pretty simple circuit written in Circom. It's just an example. The idea would be for you to see what you want to prove. There are a lot of resources on the resources link that I gave you about Circom documentation and some examples using Circom. So yeah, basically this is the circuit. It proves that you're over 18. It's super simple, but yeah. And then we have all the orchestration of using the circuit and being able to prove it on the browser and then sending it to Garaga, adapting that proof in order to verify that on chain on Starknet, and then sending that on chain. So yeah, I'm going to show you the flow first. Basically, I created this dApp. You can connect a Ready wallet if you want. Let me get rid of this for now. Okay. And that's the Ready wallet connection. And then here are the private inputs of the circuit. Right now there are two. So this would be your age. If we put 25, you would be over 18. So this should be able to prove. And then you add a salt, which is basically a random number that you will be using for not doxing the hash that you're using. So here are the inputs. We're managing all this on the repo, so if you're interested in getting some input from the user and proving that, you will be able to see that on the repo. The idea is to have a template for doing zero-knowledge proofs on Starknet. This is okay, there we go. Here is a regular proof. The public signal is 0. So this is what a proof looks like with gross 16. We have basically 3 points and then some metadata. And then the thing is that we cannot use this proof on Starknet right now. Why? Because the field size or like the bit size of the Star group is incompatible with this one. So if we were on Ethereum, you would send this, just this, and that would work. The problem is that on Starknet you cannot do that. So what we're doing on the backend of this repo is basically bringing this proof and throwing that proof to Garaga, and Garaga transform it into this thing, which is 2,000 elements like this that you're seeing here, and that would be understandable by a verifier on chain on Starknet. So what we're going to do here is the proof that we just created, we're gonna send it to Garaga, and once Garaga formatted it and prepared it for the Starknet verifier, we're gonna send that to on chain, and that would be, let me see if I can show you a little bit more here. But here is the verifier, which is done in Garaga, and this is the function that we're going to call. And then here is all the call data, the 2,000 elements that I showed you. This is what we are sending. This is the proof that we just created, but formatted with Garaga. And then, well, we click confirm, and that will send the transaction. Let's wait a bit. It's obviously going to break because this is a live demo, or not. Okay, apparently went through. Let's go to, this is on Sepolia right now, so you can check these transactions if you want. I'm not mocking. This is the transaction hash here. This is Voyager. This is like a Stark scan, but better. And here you will be able to see that we called a verify gross 16 proof BN254. Here is, which would be like 2,000 elements. And here is the return value, which is 0x1, which means true. So that, and yeah, that's pretty much it on the repo side. So the idea would be, if you want to do something related to zero knowledge, you could use this as a template for doing zero knowledge stuff on Starknet. And let me show you a bit of the code in here. So I just show you the circuit, which is like that simple thing, age verification.circom. And then we have other stuff, like, for example, the verifiers. And these are the verifiers that are generated by Garaga, which here it is. This is what Garaga generates from the original circuit that we created. So yeah, gross 16 B24. Then we have another file with a lot of constants that are used for the verifying key. And yeah, I just called the verify. Let me show you. Here it is. So this is the function that we just called. We send them this full proof with hints, which is the array of fields that I just sent, like the 2,000 fields thing, and then starts doing the math magic stuff in order to verify the proof on chain. So yeah, that's pretty much it. And you can go over the repo, and if you have any questions, you can ask me. But the idea was to just show you how to set up and bootstrap a project regarding zero knowledge on Starknet. Then let me see. Okay, here I have some scripts that lets you deploy the verifier, generate the verifier, setting up the circuits. Most of this is explained in the README. So if you follow the README, you will likely be able to generate your own version of this. You can fork this and do whatever you want, basically. Important stuff, if you're going to deploy this on Sepolia, you just have to import here your account address and your private key on Sepolia and use an RPC that works. Let me see if I'm missing something. And yeah, here are all the circuits, circuits commands. Basically, here we have the setup circuits, which is basically taking the circuits folder and generating all the important files for this to work, which would be to do the trusted setup, to generate the verifying key and the proving key and everything. That's all taken care by the script, so you don't have to worry about all that. I try to not get that deep into all the zero knowledge architecture and stuff. So yeah, but if you're interested in that, you can go look at what are the scripts doing. You can look at that at the package.json file. I can show you. Then we have this copy verification key to front end. Is basically to copy the verification key from the circuit that we are using to the application that we are serving on the front end. And this is a generate verifiers, which is basically taking the verifying key, the original one, and passing it through Garaga in order to generate the Cairo verifiers. And then I have some deploy scripts, and then basically dev, build, and clean, which will be to clean all the artifacts, build, and start a development server. And then that's the important part, basically. And then on the resources page, I gave a lot of documentation. Let me see if I can show you a bit. Okay. Here it is. Okay, this is just a list with a lot of stuff that will be useful for you if you're trying to build something on Starknet. Mostly if it's zero knowledge, but if it's like a regular decentralized application, this will become handy for you. This is here is the repo for Garaga. These are the docs for Garaga. This is the npm package for Garaga. We're using all of this on the repo that I just shared with you. Then we have some docs on Starknet, Starknet.js. The npm package on Starknet.js is really useful. You will be using that. This is just one page that was really useful for me in order to set up a connection for a Ready or Bravos wallet into your front end. This link is pretty useful. Then some links to wallets and stuff. Some SDKs that may become handy. I didn't use Starknet Kit, but I found it and may be useful for you. Then what we have? Then we have some Scarf and Cairo documentation. Then the kind of Anvil, but for Starknet, which is called Starknet DevNet. Here's the repo for that. Then here we have some Circom and SNARK.js documentation, which is basically for writing circuits and then all the tooling for making that circuits work on a browser. Then here is the repo, the link to the repo that I just showed you. And then here are some examples of people using Garaga right now. And I don't know why, but I added the blog of Starknet. There's sometimes some interesting stuff happening in there. So yeah, right now I would like to have some questions if you have some, because I try to be quick, try to do it in 30 minutes. But if you have any questions or something that you want me to cover again, or that wasn't clear enough, now is the time to ask. Let me go look at that. Okay, I see here a question. Why do you use a write function to verify instead of a read function? Why do you use a write function instead of a read function? To be honest, let me go back to the code. So maybe I can give you a better answer. But this is what so this is not written by me. This is written by Garaga. So Garaga creates these verifiers in order to make them work on Starknet, right? So this is not coded by a human, this is coded by a program. So this receives the verifying key from your original circuits and sends it to a Garaga, to a Cairo compatible way. Now, why this is a write function and not a read function, I'm not completely sure. Let's see if there's some kind of write here, but it shouldn't be a write here. Yeah, shouldn't be writing any stuff. So maybe you can add a PR to the Garaga repo and do that, but to be honest, I'm not sure about that. Okay. There's a question on Twitter.
No questions on social media. All good.
Okay, perfect.
Let's see if people in the Zoom have more questions now. Meanwhile, I'm dropping your Twitter handle and Fat Solutions Twitter handle so people can give you a follow. You can
Great.
also message Casio in the Hackathon Telegram group. So make sure if you haven't joined the Telegram group, please join it so you can interact with the mentors and ask your questions there.
Yeah, sure.
We have another question from Sergio.
Soda, yeah, obviously connect with me. Send me a message on Twitter or Telegram, whatever you want. It's okay. I would love to get more deep into anything. I try to be quick, but maybe I want to high level. I don't know. Whatever question you have, send me on Telegram. Let me see the Q&A. Post-quantum problem. Okay. If I'm not wrong, the Stark is used in Starknet for signatures hashes, but Starks are made with polynomials. What make it post-quantum a SNARK will live or not unprotected? What happens with post-quantum problem? If I'm not wrong, the Stark is used in Starknet for signatures and hashes, but Starks are made with polynomials. What make it post-quantum protected and SNARKs with elliptic curves who are not quantum protected? It's a weird question. Let me think. Post-quantum problem. I mean, everything that relies on an elliptic curve operation will probably be fucked by the post-quantum problem. You should be using something related to hashes. I think that Starks, not Snarks. I'm not talking about the Stark curve. I'm talking about Starks. Starks are quantum proof because they are based on hashes, but not sure about. I'm not following your question correctly. You will adopt Garaga in order to be post-quantum secure in some way. I'm not sure if Garaga can handle that because Groth16 depends on BN254, and if BN254 is not post-quantum secure, then Garaga cannot do anything about that. Garaga is just an adapter, but it also adapts a lot of other elliptic curves, not just BN254, but it's just an adapter, so we cannot solve the Groth16 problem, let's say. Does that answer the question? What's the difference between Noir and Circom? Should stick for max security. I heard not yet battle tested. The difference between Noir and Circom. Noir would be pretty easier to write circuits on Noir than on Circom. Circom is a pretty obscure language, to be honest. So in terms of doing, like, if you want to do a proof of concept, for example, or something quick, not necessarily quick, but if you don't want to have like 3 months of development on a circuit because Circom is like so difficult to do it, maybe Noir is a better option. Then regarding the security thing, um, it depends. On the theoretical level, Noir may be better because it has like a general setup, so it doesn't. You don't rely on a trusted setup for each circuit. So if you're talking about the trusted setup, then Noir would be better because you don't have to create a separate trusted setup each time that you do an update or you create a new circuit that you have to do on Circom. And then I heard Noir not yet battle tested, and that's another thing. Yeah, I mean, Noir is getting really hot right now. There are a lot of applications launching with Noir, but I haven't seen a big application using Noir yet, like something like Tornado Cache. To be honest, I feel more safe using Circum because there are more there is more TVL under Circum security than on Noir security. So that's if that's a way that you are okay to measure the security, then Circum is better. We need to build Tornado Cache on Starknet. Okay, we're building privacy pools on Starknet, but Tornado Cache may bring some compliance problems, but you can do it. I mean, it's not that difficult. If you are interested in that, you can send me a message and I can help you, give you some ideas on how to do it. Okay, I would like to learn more. Can you share your Telegram? Yeah, my Telegram is the same as my Twitter handle. It's my Telegram is, there we go. Then okay, I think that's it.
Yeah, I think we're
If
all
you have
covered.
more questions, send
It's the
them.
best workshop by far.
Really? Thank you, Sergio. Oh, about formal verification. I don't know shit about formal verification, Sergio. Sorry, but I have a coworker at desk. So if you're interested in that, maybe I can give you some information about that. Looks like the circuit, yeah. Um. So yeah, if you have any questions on or if you want to go deep into a specific point in here, please tell me and send me a message on Telegram or Twitter or whatever, and we can discuss anything. It really interesting for me. I didn't know how to handle the high level, low level on this workshop, so yeah, I'm just trying. So if you have any feedback or whatever, please send me. And yeah, I
Perfect.
think
I think there's
that's
no more
it.
questions. We can maybe wrap it up.
Okay.
Perfect. Thank you, Casio.
Well,
Thank you, everyone, for joining.
thank you
Happy
guys.
hacking.
Happy
Bye.
hacking. Bye bye.